This is a question on reflection in a plane mirror, and is a slightly different variant of the question on what is the minimum length of the mirror needed for you to see the full picture. Now in this question, you are given that the mirror is only 20 cm, and you're asked how much of the object can you see. The object in this case is the rear window. So it's a slightly different type of question, but the technique to solving this is again the same. So we will locate the object and the image position accurately, and we will then draw in the three light rays, how I perceive the image, which is a straight line, and number two, incident ray, and number three, reflected ray. And lastly, for this type of question, we need to use similar triangles to solve and calculate the answer out. So let's get right to it. So we can see that the window is being drawn for you. The driver is in the roughly in the between the mirror and the window. So the distances is given to you. So over here, the actual window is 550 cm away from the mirror. So I can use the object distance equals to image distance relationship to then draw in where the image of the real window is. So I've done that, and you can see that on the top of the slide, I have now drawn in the image of the window, and the distance is 550 cm away behind the mirror. Now the next step is to draw in the light rays. So the first light ray that we always draw is how our eye perceive the image. So as you can see here, I've drawn two dotted lines here from the driver all the way to the edge of the mirror and going straight to the image. Same thing from the driver, passing by the edge of the mirror to where the image is. And you notice that we can't see the full window. We get cut off here. Now, remember that a mirror allows reflection to happen. So if there is a mirror here, there can be a reflection, and that's how you can see the image. If there is no mirror, we cannot see, or there wouldn't be any reflection, and therefore we can't see. Therefore, what I've done here is to use the edge of the mirror as a guide to look at the greatest path that I can see as a driver. So with that, I can now draw in the actual incident rays and the reflected rays, and this is drawn in blue, and therefore right now I can see that this is the length of the image that I can see from here all the way to only here, from here all the way to here. So that is what I'm aiming to determine, and that will be the answer. So if it's drawn to scale, we can always measure it using a ruler and then convert it to the scale using the scale. But again, we can make use of similar triangles to solve for this. So the answer is 240 cm, and again, same method. Let's look at two triangles. Number one, triangle A, the bigger one, and triangle B, the smaller one. And these two triangles are similar. So for similar triangles, the rule is that the ratio of the sides is the same. So right now, I'm going to use the height of A, which is from here to here. This is the height. And this, if you add up the numbers, you will get 600 cm. And the height of B, which is the smaller triangle, is just over here, and that's only 50 cm. So I can get this ratio to be 12:1. And the ratio applies to the base of A, which is the answer that we're looking out for, and the base of B, which is the length of the mirror, 20 cm. So plugging in the values, we can get the answer of this to be 240 cm.